which is
Down.
MathDali.
Have you ever wondered how mathematics and science are linked? Well, mathematics and science are like two sides of the same coin. Math provides the structure and a position, while science adds the curiosity and application. Whether calculating the orbit of a planet or unraveling the mysteries of quantum mechanics, the two work hand in hand to decode the universe. Together, they remind us that understanding the world requires both logic and explanation. Application problems related to logarithmic function by MathDali. Mathematics is the language of science providing multiple tools for multiple sectors. It enables precise predictions and more. Concepts that are found in mathematics can also be fundamental to scientific fields.
Logarithmic functions are the inverse of exponential functions. It is written as y is equals to log x to the base b, where b is the base of the logarithm, x is greater than 0, and y is the exponent to which the base b must be raised to produce x. They are extremely important because they model relationships where growth and decay rates change over time. And with its unique property, we will be able to solve problems which involves growth patterns and changes in perspectives.
Now, as you might recall, in the beginning of this video, we have presented a few clips which are connected to our situations which are presented in this slide right now. This is our first sample problem, which to be explained by my co-elaborator.
So for earthquake magnitude, this is the formula. So R is equals to 2/3 log E over 10 raised to 4.40, where E in joules is the energy released by the earthquake, and the quantity 10 raised to 4.40 is the energy released by a very small reference earthquake. Now, please take note that 10 raised to 4.40 is a constant number, therefore it cannot be changed. For example, suppose that an earthquake releases approximately 10 raised to 19 joules of energy. Now we will look for A and B. For A, what is its magnitude on a Richter scale? Now, we will substitute the given number 10 raised to 19 with the variable e. Therefore, it will then become r is equal to 2/3 log 10 raised to 19 over 10 raised to 4.40. Now, as we all know, in dividing fractions with the same bases but different exponents, we will subtract its exponents. So that will then become 2/3 log 10 raised to 14.6. Then we will cancel out log 10, and that will become 2/3 times 14.6, which will then become 9.73 or 10, as we need to be specific in identifying the magnitude and its definition. So this is a table for the description of that specific magnitude. And with that, it is magnitude 10. It is completely devastating, and it's practically all man-made structures are destroyed. For letter B, sound intensity. This is the formula. In acoustic, the decibel level of a sound is D is equals to 10 log I over 10 raised to negative 12, where I is the sound intensity in watts per meter squared, and the quantity 10 raised to negative 12 watts per meter squared is the least audible sound a human can hear. So, an example of this is the decibel level of a sound in a quiet room is 10 raised to negative 8 watts per meter squared. Now we will look for A and B. For letter A, what is the corresponding sound intensity in decibels? So, we will substitute that given number to variable I. Therefore, it will then become D is equal to 10 log 10 raised to negative 8 over 10 raised to negative 12. So, with the same thing, we will subtract the exponents as it has same basis. So that will then become 10 log 10 raised to 4, which will then become 10 multiplied by 4, and then will become decibel 40. So for letter B, this sound is 10,000 times more intense than the least audible sound a human can hear. So in identifying that, we will use this table again. So it is under 60 decibel, therefore it fits the description of comfortable hearing levels: normal breathing, whisper, quiet office, and normal conversation. So for the last one, pH level, This is the formula. In chemistry, the pH level measures the acidity of water-based solution that is measured by the concentration of hydrogen ions, written H plus in moles per liter in the solution. So these are the two solutions or the two equations that we can use, and we might use one of each. Okay, so for example, a 1 liter solution contains 1,000 mole of hydrogen ions. We will find its pH level. So we will use this specific formula. So since there are 1,000 mole of hydrogen ions in 1 liter, then the concentration of hydrogen ions is 10 raised to negative 3 moles per liter. It is simply the substitution of 1,000 to 10 raised to negative 3. So that will then become pH is equals to negative log 10 raised to negative 3, which will then become negative times negative 3, then becomes pH is equals to positive 3. So in finding common examples of that specific pH level, we will use this table. So it is pH level 3, therefore it fits with orange juice and soda.
Here are some sample problems which you may try for yourself.
So thank you for listening to MathDali. I am Mallory Angel L. Charisma, an elaborator.
And I am Trixie Mestelero, her co-elaborator in this video.